We could have already discussed with cube roots of unity. Now we shall be ready to go to deal with fourth roots of unity and then nth roots of unity. What are fourth roots of unity? The roots of the equation x power 4 is equal to 1 are nothing but the fourth roots of unity. Let us now try to solve it. X power 4 is equal to 1 implies x power 4 minus 1 is 0. It can be factorized as x square plus 1 into x square minus 1. Again, it is an easy matter to go through that x plus I into x minus I, x plus 1 into x minus 1 is equal to 0. It could be split in terms of 4 factors, linear factors, which give us the roots x is equal to minus I minus 1, 1. These are of course called the fourth roots of unity. These are called the fourth roots of unity. Well, as every one is a fourth root of unity, we can say minus I whole power 4 is 1, I power 4 is 1, minus 1 whole power 4 is 1, and 1 is 1 also. 1 is 1 also. Yes, we now observe the integral parts of I and minus I. What will be this general behavior of those things? What is I power 1? I. What is I square? Minus 1. What is I cube? I square into I. That is minus 1 into I. That is minus I. I power 4 is equal to 1. Why is it 1? I square whole square, that is minus 1 whole square, that is 1. Not only that, I is the fourth root of unity, that is the root of the equation x power 4 is equal to 1. Hence it should satisfy that equation. So I power 4 is equal to 1. Now you add all of these things. What is going to happen? I plus I square plus I cube plus I power 4 is equal to 0. That is a good symptom for us to state so many important concepts. I power 1, I power 2, I power 3, I power 4. You observe, they are 4 successive integral powers of I whose sum is 0. So by looking at that, can we be in a position to say that the sum of all 4 successive integral powers of I, whatever 4 successive integers you can have, is 0? Yes, why not? Look here, as I power 4 is 1, I power 4n is always 1, because I power 4 whole power n is 1. If it is I power 4n plus 1, what is this? I power 4n into I power 1. I power 4n is 1 into I is I power 4n plus 2. What is this? I power 4n into I square. What is I power 4n? 1. I square is minus 1. I power 4n plus 3 is I cube, is minus y. Add all of them. Again you will be getting 0. You see, I power 4n, I power 4n plus 1, I power 4n plus 2, I power 4n plus 3. What can you say about them? They are nothing but 4 consecutive integral powers of I. Moreover, it is sure that if you select any set of 4 consecutive integers, they can be put in the form 4n, 4n plus 1, 4n plus 2, 4n plus 3 for some integer n. No doubt about it. Thereby, we declare that the sum of 4 consecutive integral parts of I is always 0. Is always 0. Now, what happens when only even parts of I are calculated, only odd parts of I are gathered and added? What is going to happen? Let us now see. What is I square plus I to the power of 4? What is I square? Minus 1. What is I power 4? 0. What is I square? minus 1. What is I power 4? 1. Minus 1 plus 1, 0. Just like that, I power 6 plus I power 8. How can it be? I power 6, I power 4 plus 2 is nothing but I square. This is I square and this is I power 4 whole square is 1. I square is minus 1 plus 1, 0. You take any two successive integral powers, successive even integral powers, that is I to the power of 26 plus I to the power of 28. How can it be? What is I power 26? 6 4s are 24. 24 plus 2. So I power 24 into I square is I square. This is minus 1, this is plus 1, 0. What do you say? Any two successive even integral powers of I is always 0. Now you try to estimate. I power 0 plus I power 2 plus I power 4 plus I power 6 plus I power 8 plus I power 10 plus and so on, etc. I to the power of 98. What can it be? How many terms are here? How many terms are here? This is, how can you estimate? You close this. I square, I power 4, I power 6, I power 8, I power 10 and so on, I power 98. How many terms are here? 2 1s, 2 2s, 2 3s, 2 4, etc. 2 49s. So these are 49 terms, including this 50. 50 terms are there. 50 terms are there. So 50 is an even number. 50 is an even number. Well, two successive powers, 0, 0, 0, 0, 0, 0 is 0. For every two successive powers, the sum is 0, 0, 0, 0, 0. As these are 50 in number, if you collect two terms like that, nothing will be remain. So it is 0. Now let me change this question. I square plus I power 4 plus I power 6 plus I power 8 plus etc. 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 I to the power of 66. What is the answer? What is the answer? Now, how many terms are here? 2 1s are, 2 2s are, 2 3s are, 2 4s are, 2 33 T's are. How many terms are here? 33 terms are here. How many? 33. Now, you try to estimate this sum as I power, you observe the previous term also. It is I power 64. So far, how many terms are there? 32 terms are there. If you add 2 terms, 0, 0, 0, 0, like that. Here up to this point we have 32 terms, so it is 0. So what remains? I power 66 only remains. What is I power 66? 66 means I power 64 into I square, isn't it? Up to here it is 0. Here I power 66 is nothing but I power 64 into I power 2. This is 1 and this is minus 1. So total answer is minus 1. Like that we estimate. So if all even powers of I are given, we choose like this. Okay, what happens when odd powers of I are given? Let us see. I power 1 plus I power 3. I power 5 plus I power 7. I power 9 plus I power 11. What is the answer? What is I cube? I square into I. I square into I means minus 1 into I. Minus I. I minus I, 0. I power 5 is I. I power 7 is I cube. I plus I cube was already 0. I power 9 is I power 8 into I. I power 11 is I power 8 into I cube. Again it is I plus I cube, which is already 0. So if you have like this, any two successive or integral powers of I is also 0. Is also 0. Now you estimate this. I plus I cube plus I power 5. plus etc 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 I power 2n minus 1 is equal to. How can you estimate this? Right. 1, 3, 5, 7 etc 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 2n minus 1. How many terms are in this sum? N terms are there. How can you recollect? It's very simple. 1, 3, 5 etc 2n minus 1 is an AP whose nth term is 2n minus 1. So there are n terms. There are n terms. Now two cases will arise. What happens when n is even? What happens when n is odd? That we have to know. What is that? Case 1. Let n be even. If n is even, then 0, 0, 0, 0, 0, 0. Therefore, 0 if n is even. If n is even. Well, what happens when n is odd? What does it mean? In this sum, there are odd number of terms. If you pick out 2 terms, 2 terms, 2 terms, 2 terms like that, one term will be left behind at the end. What is that term? I power 2n minus 1. What is I power 2n minus 1? I square whole power n into I power minus 1. Isn't it? Yes, of course. What is I square minus 1 whole power n by I? What is n? We are discussing with n as an odd number. Minus 1 whole power an odd number is again minus 1 by I. Multiply with I and I. What happens? I into I square. Minus 1 no minus 1. They will be cancelled, leaving you I. So what is that what is the answer actually? I is equal to I if n is odd. The thing that you have to notice is, while estimating this sum, why are you interested to consider the last term only? That I want to have. N is odd. The number of terms present here is odd. We know that the sum of two odd integral parts of I is 0. 0, 0, 0, 0. You pick out two things, two terms like that. At the end, one term will be remain. What is that term remaining? The last term. What is that? I power 2n minus 1. I power 2n minus 1 of course can be simplified like this. I square is minus 1 whole power n. I power minus 1 is by I. Minus 1 whole power n is minus 1. Why is it minus 1? Because we are considering n as an odd integer. If n is an integer, no question of any discussion at all. It will be 0. No problem at all with that. N is odd. In that case, we are now. Therefore, as n is odd, minus 1 whole power n is minus 1. Minus 1 by I. Multiply it with I. Both numerator and denominator. You will be having it is I. What is I into I? I square. Minus 1 i's. Not only that, you can simplify this like this also. Minus 1 by I. In the place of minus 1, you can write I square. I square by I is again I. Therefore, the answer is I. You are supposed to keep these points in our mind while it is needed for us to simplify the things in which omegas and i's are involved. Yes. Now it is our turn to look at nth roots of unity. What are they called? The roots of the equation x power n is equal to 1. The roots of the equation x power n is equal to 1. And this is nothing but cos 0 plus I sin 0. That is nothing but cos 2k pi plus I sin 2k pi. I sin 2k pi. So x is equal to cos 2k pi plus I sin 2k pi whole to the power of 1 by n is equal to cos 2k pi by n plus I sine 2k pi by n. What is k? For k is equal to 0, 1, 2, 3, etc. n minus 1. Why should we take up to n minus 1? Only because you like to have nth roots of unity. If you count them, it should have only n and only n roots, because it is an equation of nth degree. It is supposed to have n and only n roots, and if you change the value of k, another root is going to be obtained. Of course, this step is had by using De Moivre's theorem. Of course, we discuss it now. This is a x. The values of x for k is equal to 0, 1, 2, 3, etc. and minus 1 are nothing but called nth roots of unity, and this can again be called e power I 2 k pi by n. K is equal to 0, 1, 2, 3, etc. and minus 1, where e power I theta is equal to cos theta plus I sin theta, according to the famous definition due to a famous mathematician Euler. Yes, this we call Euler's definition. Cos theta plus I sin theta is just nothing but e power I theta, and in the place of theta we have here 2k pi by n. 2k pi by n. If k is 0, it is 1. If its k is 1, then e power I 2 pi by n. Now, I like to write this as 1 omega, omega square, omega cube, omega power 4, and etc. omega power n minus 1, where omega is equal to e power I 2 pi by n. E power I 2 pi by n. If k is 0, e power 0 is 1. If k is 1, e power I 2 pi by n. If k is 2, e power I 4 pi by n, and so on. These are the nth roots of unity. We call automatically, what is the product of nth roots of unity? What is the product of nth roots of unity? Minus n whole power n into minus 1 actually. Because using theory of equations, x power minus 1 is equal to 0 is the equation. There are n roots, product of nth roots of unity is of course here minus 1 whole power n into last term by first term, that is minus 1 whole power n plus 1 is the answer. Product of nth roots of unity. Here it is an interesting case. From this step we will be able to have both the cube roots of unity and fourth roots of unity also by choosing n suitably. Suppose you take n is equal to 3. What happens? If n is equal to 3, only 3 things we have. 1, omega, omega square. What is omega? E power I 2 pi by 3. What is omega square? E power I 2 pi, e power I 2 pi by n is 3. Omega square, e power I 4 pi by 3. So thereby you will be able to have the mod amplitudes forms for omega and omega square also here. If you want to have fifth roots of unity, what is the case? 1 omega, omega square, omega cube, and omega power 4. And omega power 4. If you want to have sixth roots of unity, proceed like that. This is the matter connecting nth roots of unity. And while finding these nth roots of unity, we could have made use of one beautiful concept, namely De Moivre's theorem. What is that? Let us have a look over that. One of the most important, the most useful concepts which helped us a lot in various calculations in complex numbers is De Moivre's theorem. Yes, a remarkable change and a remarkable utility is being observed in the set of complex numbers, of course, simply by means of De Moivre's theorem. What is that? What is that? Let us now learn. If theta is a real number, De Moivre's theorem says that cos theta plus I sin theta whole to the power of n is equal to cos n theta plus I sin n theta. This has been proved in almost all the cases of n. If n is a positive integer, it is correct. If n is a negative integer, it is correct. If n is a rational number, also it is correct. So we will be making use of this result. Cos theta plus I sin theta whole to the power of n is equal to cos n theta plus I sin theta. And by using Euler's definition, cos theta plus I sin theta is just nothing but e power I theta. E power I theta whole to the power of n is equal to e power I n theta. E power I theta whole to the power of n is equal to e power I n theta. E power I n theta. Moreover, if z is equal to r into cos theta plus I sin theta, then this z can be written as z is equal to r into e power I into amplitude of z. Amplitude of z is nothing but theta. Therefore, by making use of that, we can also say one more thing. Suppose you have z square. It is given that the amplitude of z is theta. What is the fate of z square? What is the amplitude of z square? How can you have? Amplitude of z square I want to have. Amplitude of z square is equal to amplitude of, what is that? R into e power I theta. That is r square into cos theta plus I sin theta whole square. For this complex number, using De Moivre's theorem, it can be taken as cos 2 theta plus I sin 2 theta. Amplitude of this is nothing but 2 theta. 2 theta is equal to 2 into what is theta? Amplitude of z. Not only that, if you are asked to have amplitude of z cube, what is the amplitude of z cube? 3 into amplitude of z. What is the amplitude of z power n? N into amplitude of z. You can have. Yes. This is the basic concept which is offered by De Moivre's theorem for us. And when you have an exponent for this Euler's form e power I theta, it can take the form e power I n theta. This has a wide range of applications. Let us now look at those applications. Let z is equal to a plus ib. Then what is z bar? A minus ib. Automatically is equal to r into cos theta plus I sin theta. Then this is r into cos theta minus I sin theta. What can you observe here? If amplitude of z is theta, amplitude of z bar is minus theta. Amplitude of z bar is minus theta. Isn't it? Right. One more thing. Suppose z1 is equal to r into cos alpha plus I sin alpha. Z2 is equal to r into cos beta plus I sin beta. We see that amplitude of Z1 is alpha and amplitude of Z2 is beta. Now, if you multiply this Z1 and Z2, what is going to happen? R1, R2 into cos alpha plus I sin alpha into cos beta plus I sin beta. Usual trigonometric multiplication and transformations, you can see that it is nothing but cos of alpha plus beta plus I into sin of alpha plus beta. And Z1 by Z2 is R1 by R2 into cos alpha plus I sin alpha by cos beta plus I sin beta. If you multiply with cos beta minus I sin beta, both numerator and denominator, it can be taken as cos alpha minus beta plus I sin alpha minus beta. It is not the matter to find Z1, Z2 and Z1 by Z2 here. It is beneficial to note the amplitude of the product and the quotient. Amplitude of Z1 is alpha, amplitude of Z2 is beta, then amplitude of Z1, Z2 is alpha plus beta. Amplitude of Z1 by Z2 is alpha minus beta. Of course, while noting this, you may recollect and recall one more thing. This cos alpha plus I sin alpha is in a short symbolism, it is read as cis alpha, C for cosine, I for imaginary I, S for sin, cos alpha plus I sin alpha. This is R2 into cis beta. This is R1 R2 into cis alpha plus beta. This is R1 R2 into cis alpha minus beta. Cis alpha minus beta. Therefore, here we could have made use of two things. What are they? Cis alpha into cis beta. What is that? Cis alpha plus beta. Cis alpha by cis beta. What is that? Cis alpha minus beta. By making use of those two things, we are able to have. And what is the inference? What is the conclusion that you can make by observing these things? Amplitude of Z1, Z2 is equal to, come on, trace the answer. Amplitude of Z1, alpha. Amplitude of Z2, beta. Amplitude of Z1, Z2, alpha plus beta. Alpha plus beta is nothing but what is alpha? Amplitude of Z1 plus amplitude of Z2. Amplitude of Z1 plus amplitude of Z2. Similarly, amplitude of Z1 by Z2. How can you make it? Z1 by Z2, you could have written as R1 by R2 into cis alpha minus beta, that is cos alpha minus beta plus I sin alpha minus beta. Hence the amplitude is alpha minus beta, that is amplitude of Z1 minus amplitude of Z2. These two are the important things that you may have to recollect. That is the case. Well, suppose Z is R into cis alpha. What is 1 by Z? 1 by R1 into cis alpha. 1 by R1 into cis alpha. Right. Let us now observe that transformation. Suppose Z is equal to R into cis alpha. Then what is 1 by Z? 1 by R into cis alpha. This is equal to cis 0 by cis alpha. Just previously we could have noticed that cis alpha by cis beta is cis alpha minus beta. What is cis 0? Cos 0 plus I sin 0. 1 plus I 0 is 1. Cis 0. Cis 0 by cis alpha is nothing but 1 by R into cis minus alpha. Amplitude of Z is alpha, then amplitude of 1 by Z is minus alpha. Amplitude of Z is alpha, then amplitude of minus Z is minus alpha, that is minus amplitude of Z. Minus amplitude of Z. Either minus alpha or pi minus alpha also you can take, because cos of minus alpha plus sin of minus alpha, cos alpha minus sin alpha, it is okay. But with respect to the quadrant in which Z and Z bar lie, you can say that the amplitude of 1 by Z can also be pi minus alpha. And more generally it is minus alpha, that is minus amplitude of Z. That is an additional thing to be noted here by using, of course, De Moivre's theorem. Cis 0 by cis alpha is nothing but cis minus alpha. Yes. Next one. 1 plus I whole to the power of n plus 1 minus I whole to the power of n is equal to some 4 options he may give. 2 power n plus 1 into cos of n pi by 4, 2 power n into cos of n pi by 4, or 2i into sine of n pi by 4, like that. Some 4 options will be given how to make use of that. Yes. Here also we use 2 concepts here. One concept is of mod amplitude form and the other concept is of De Moivre's theorem. Let me first know what 1 plus I whole to the power of n is. 1 plus I whole to the power of n is equal to, first of all I am interested to write 1 plus I in mod amplitude form. How can it be? 1 plus I is equal to r into cos theta plus I sin theta. Here r is equal to root of a square plus b square, that is root 2, and theta is equal to tan inverse b by a, 1 by 1, that is 1. You see the quadrant in which 1 plus I lies, first quadrant. Therefore theta should lie between 0 and pi by 2. Theta should lie between 0 and pi by 2, hence it is pi by 4. Therefore this 1 plus I can be taken as root 2 into cis pi by 4 whole to the power of n. Whole to the power of n. Good. This is therefore root 2 power n into cos pi by 4 plus I sin pi by 4 whole to the power of n. This is again root 2 power n into cos n pi by 4 plus I sin n pi by 4. Of course, by making use of De Moivre's theorem. Again, this we could have estimated like this, and in a similar fashion 1 minus I whole to the power of n can also be taken and considered as to be simplified as cos n pi by 4 minus I sin n pi by 4. You just consider the conjugates on both the sides. You'll be having this. And therefore, by adding these two, the requirement, that is 1 plus I whole to the power of n plus 1 minus I whole to the power of n is equal to, you add these two things will be cancelled. Cos n pi by 4 plus cos n pi by 4 is 2 cos n pi by 4. So it is root 2 power n means 2 power n by 2 into 2 cos n pi by 4 n belongs to Z. This is the answer. 2 power n by 2 into 2 is 2 power n by 2 plus 1. Well, my dear, what I like to say you is, you need not put all these steps. These can be imagined in your mind itself. Yes, of course. Very, very easy steps. 1 plus I, r is root 2. Theta is tan inverse v by a, that is 1 by 1, tan inverse 1, and it lies in the first quadrant, hence it is pi by 4. Therefore 1 plus I can be taken as root 2 into cis pi by 4. By using De Moivre's theorem, you will be able to have directly this step. And by adding this, of course, it's just nothing but the conjugate of this. You will be getting 2 into real part of this, that is 2 into cos n pi by 4. So it is not at all to imagine it, not at all difficult to imagine it. You need not calculate it. Just like this, you will be able to have a sum of the form 1 plus I root 3 whole to the power of n plus 1 minus I root 3 whole to the power of n. You can of course. What is the mod amplitude form of 1 plus I root 3? What is r? Root of 1 plus 3, 2. What is theta? Tan inverse root 3 by 1, 60. Why? Because 1 plus I root 3, the complex number that can be represented as the point 1 root 3 in the first quadrant. Therefore theta is pi by 3. Hence the upcoming answer will be 2 power n into 2 cos n pi by 3 instead of pi by 4. So this answer will be 2 power n plus 1 into cos n pi by 3, like that. To estimate such things, we are able to use De Moivre's theorem and Euler's definition, cos theta plus I sin theta, properties of cis alpha, cis beta, like that. Next, We shall now look at some more applications of this concept. We shall now switch over to some more applications of the Himayath theorem. Suppose there are three real numbers alpha, beta and gamma such that cos alpha plus cos beta plus cos gamma is equal to 0 is equal to sin alpha plus sin beta plus sin gamma. With this just simple information, simple piece of data, a lot of things can be deduced. Out of them, sin cos alpha plus beta plus cos beta plus gamma plus alpha is equal to 0. Sin of alpha plus beta plus sin of beta plus gamma sin of gamma plus alpha is equal to 0. Cos 2 alpha plus cos 2 beta plus cos 2 gamma is equal to 0. Sin 2 alpha plus sin 2 beta plus sin 2 gamma is equal to 0. Sin square alpha plus cos square, like that, so many things you can have. What are they? Number 1, sigma sin alpha plus beta is equal to 0. Sigma cos alpha plus beta is equal to 0. Sin alpha plus beta plus sin beta plus gamma plus sin gamma plus alpha, 0. Similarly, cos alpha plus beta plus cos beta plus gamma plus cos gamma plus alpha, 0. Another thing, sigma sin 2 alpha is equal to 0. The same, sigma cos 2 alpha is also 0. Another, sigma sin square alpha, that is sin square alpha plus sin square beta plus sin square gamma is equal to 3 by 2 is equal to sigma cos square alpha, that is cos square alpha plus cos square beta plus cos square gamma. Another thing you can derive is cos 3 alpha plus cos 3 beta plus cos 3 gamma is equal to 3 into cos of alpha plus beta plus gamma. And similarly, sigma sin 3 alpha can be taken as 3 into sin of alpha plus beta plus gamma. Like that, you can be having so many such things. For all these results, that is the basic piece of data. With that just simple step, we'll be able to have all this. How can we? Let us have a brief discussion about it. Not the full length proof, but a brief discussion. Okay, take A is equal to cos alpha plus I sin alpha. B is equal to cos beta plus I sin beta. C is equal to cos gamma plus I sin gamma. From this you will be able to have 1 by A is equal to cos alpha minus I sin alpha. From this 1 by B is equal to cos beta minus I sin beta. 1 by C is equal to cos gamma minus I sin gamma. You can now add all these things. What do you get? A plus B plus C is equal to cos alpha plus cos beta plus cos gamma, that is 0, plus I into sin alpha plus sin beta plus sin gamma, 0 is equal to 0. Moreover, even if you add this 1 by A plus 1 by B plus 1 by C, this is also 0. So A plus B plus C is 0 and 1 by A plus 1 by B plus 1 by C is 0. Good. A plus B plus C is 0 means A plus B plus C whole square is also 0. A plus B plus C whole square is 0. What is A plus B plus C whole square? A square plus B square plus C square plus 2AB plus 2BC plus 2CA is equal to 0. This is equal to minus 2 into AB plus BC plus CA. Is just nothing but minus 2ABC into 1 by A plus 1 by B plus 1 by C. What is 1 by A plus 1 by B plus 1 by C? 0. So this is 0. A square plus B square plus C square is 0. Now you observe, what is A square? Cis 2 alpha. What is B square? Cis 2 beta. What is C square? Cis 2 gamma. So if you add all those things, what are you going to have? Cos 2 alpha plus cos 2 beta plus cos 2 gamma plus I into sin 2 alpha plus sin 2 beta plus sin 2 gamma is equal to 0. Therefore, you will be able to have two results at a time. What are the results? Sigma cos 2 alpha is 0 and sigma sin 2 alpha is equal to 0. Moreover, from this you will be having AB plus BC plus CA is also 0. Why? AB plus BC plus CA is nothing but ABC into 1 by A plus 1 by B plus 1 by Z, which is 0. Hence it is 0. That is cis alpha into cis beta plus cis beta into cis gamma plus cis gamma into cis alpha, 0. That is cis alpha plus beta plus cis beta plus gamma plus cis gamma plus alpha is equal to 0. Thereby sigma cos alpha plus beta 0 and sigma sin alpha plus beta 0, you could have had 4 results again. Now from this you have sigma cos 2 alpha is equal to 0. What is sigma cos 2 alpha? Sigma 2 cos square alpha minus 1 is equal to 0. That is 2 into sigma cos square alpha is equal to 3. That is, by applying sigma, you will be having minus 3 this side, and if you send to that side, it becomes 3. So sigma cos square alpha is equal to 3. Not only that, you can write cos 2 alpha as 1 minus 2 sin square alpha also. Thereby you will be getting sigma sin square alpha is equal to 3 by 2. So if you square on both sides, you will be having 4 to 6 results at a stretch. One more thing. A plus B plus C is 0 we have had. If A plus B plus C is equal to 0, you will be having A cube plus B cube plus C cube is equal to 3ABC. What is A cube? Cis 3 alpha. Cis 3 beta. Cis alpha plus beta plus gamma. 3 into. You expand this sigma and compare the real and imaginary parts. You will be having cos 3 alpha plus cos 3 beta plus cos 3 gamma is equal to 3 into cos of alpha plus beta plus gamma, and sin 3 alpha plus sin 3 beta plus sin 3 gamma is equal to 3 into sin of alpha plus beta plus gamma. So we are able to get almost all the results we could have listed previously, simply because of this simple result, that is sin alpha plus sin beta plus sin gamma is equal to 0 is equal to cos alpha plus cos beta plus cos gamma. Not only that, you can extend this result to another step also. What is that? Let us see. Suppose you have 3 real numbers LMN such that L cos alpha plus M cos beta plus N cos gamma is equal to 0 is equal to L sin alpha plus M sin beta plus N sin gamma. By representing them with a suitable complex numbers as in the previous case, we will be able to write that L cube cos cube alpha plus M cube cos cube, L cube cos 3 alpha plus M cube cos 3 beta plus N cube cos 3 gamma is equal to 3 LMN into sin of alpha plus beta plus gamma, cos of alpha plus beta plus gamma. Like that, you will be able to write. Simply because of the previous activity, we will be able to choose a suitable complex number such that this happens and we get that result. These are few applications, direct applications of De Moivre's theorem and mod amplitude form. Some more results are also there we shall be looking at. That is a matter of obtaining the fourth roots of 1 plus I root 3. What are the fourth roots of 1 plus I root 3? Immediately you can have fourth roots of 1 plus I root 3. We want to have 1 plus I root 3 can be taken as, what is the mod amplitude form? Modulus is 2, amplitude is 60 degrees, 2 into cis pi by 3 whole to the power of 1 by 4 is equal to, instead of pi by 3. Let us now have general amplitude, that is 2k pi plus pi by 3 whole to the power of 1 by 4. General amplitude, not fundamental amplitude. Not fundamental amplitude, but general amplitude. Then we require to have fourth roots of unity where k is equal to 0, 1, 2, 3. Stop. Likewise, you can have sixth roots of the given complex number, seventh roots of the given complex number, eighth roots of the given complex number, as you like, provided you are supposed to have general amplitude but not fundamental amplitude, because you will be able to write different values of k regarding with respect to the number of roots you are supposed to have. We are supposed to calculate fourth roots, therefore we take 4 values for k like that, and you can simplify. You can have all the results. In some questions we will be asked to find the product of all the fourth roots of the given complex number, or the sum of all the sixth roots of the given complex number, product of the etc, etc, etc. You will be asked. It is an easy matter, of course. Next one. Here is the most important part of complex numbers. That is the geometrical applications and the significance of complex numbers in geometry. That we are now going to recollect the things. Let us now deal with some more applications of complex numbers geometrically. We recall that if z is equal to x plus iy is a complex number, then it can be considered, it can be represented as the point pxy in the organed plane. And moreover, the complex number z is supposed to correspond to the vector OP bar. To the vector OP bar. OP bar. Right. Let me write z1 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2. There are two complex numbers. Then this is z1 is equal to x1 plus yy1. Let me express z1 in mod amplitude form as r1 into cis theta 1, that is cos theta 1 plus I sin theta 1, and z2 is equal to r2 into cis theta 2. What do you say about theta 1, amplitude of z1? What do you say about theta 2, amplitude of z2? Now this angle is theta 1, this angle is theta 2. What do you say about this angle? Imagining this to be x-axis, from our supposition amplitude of z1 is theta 1 and amplitude of z2 is theta 2. Therefore, this is the angle theta 1 and this is the angle theta 2. This is automatically theta 1 minus theta 2. Theta 1 minus theta 2. Theta 1 minus theta 2. What is theta 1 minus theta 2? What is theta 1 minus theta 2? It is nothing but argument of z1 minus argument of z2. Is nothing but argument of z1 by z2. That is cis theta 1 by cis theta 2 is nothing but cis theta 1 minus theta 2, isn't it? Therefore, we say that angle POQ is equal to theta 1 minus theta 2 is equal to amplitude of Z1 minus amplitude of Z2 is equal to amplitude of Z1 by Z2. Amplitude of Z1 by Z2. Hereafter, we use this concept for many number of times. Yes, amplitude of Z1 and Z2 is nothing but the angle between OP and OQ. Of course, if you replace x1, y1 and x2, y2, theta 1 and theta 2, it can be considered as Z2 by Z1, argument of Z2 by Z1 also. The main concept that must be grasped here is, if two complex numbers Z1 and Z2 are given, by argument of Z1, Z2, we mean the angle between the two vectors OP bar and OQ bar. That is the angle POQ. Provided the complex numbers Z1 and Z2 are of course considered as the vectors on orgone plane. Moreover, this we can extend to so many geometrical configurations and consequences also. Suppose you have a triangle, say Z1, Z2, Z3. By the by, if this is OP bar and this is OQ bar, what can you say about PQ bar? OQ bar minus OP bar, that is Z2 minus Z1. Okay, I am naming them. This is A, B, C. I like to have angle at B, angle ABC. What do you have? What is BA bar? Z1 minus Z2. What is BC bar? Z3 minus Z2. Isn't it? I consider this to be origin. And what does it mean? I shift the origin to this point, say. Then what is that? This angle minus this angle, that is argument of Z1 minus Z2 by Z3 minus Z2 is of course nothing but angle ABC. It is BA bar and BC bar. The angle between them is argument of this minus this. Here you have to say, okay, for one particular thing, if OP bar and OQ bar are given, what is PQ bar? OQ bar minus OP bar from our knowledge of vector algebra. Just like that here also, AB bar and AC bar, how can you write? What is BA bar? Z1 minus Z2. What is AB bar? Z2 minus Z1. What is BC bar? Z3 minus Z2. As we require the angle at B, we should consider the vectors as BA bar and BC bar. Therefore, argument of Z1 minus Z2 by Z3 minus Z2 is just nothing but the angle between ABC, angle at B. Suppose you may be given an equilateral triangle, say. If Z1, Z2, Z3 are the equilateral vertices of equilateral triangle, then what can you say about argument of Z1 minus Z2 by Z3 minus Z2? Pi by 3. Pi by 3. Like that we will be having. Suppose Z1, Z2, Z3 are vertices of a right angle triangle, right angle at Z2. Then what happens? Z1, Z2, Z3 are the vertices of a right angled triangle. So argument of Z1 minus Z2 by Z3 minus Z2 is nothing but pi by 2. Pi by 2. Like that we will be able to have. This is application of argument or amplitude in geometrical figures. Yes. Now let us see some more things, some standard results in the case of equilateral triangles, isosceles triangles, etc. What is the case with that? Suppose we have Z1, Z2, Z3, Z4. It is a pair of complex numbers. This is a pair of complex numbers. These two complex numbers correspond to two distinct points on orgone plane, and these two complex numbers also correspond to two more distinct points, say AB and CD. What is the angle between AB bar and CD bar? What is the angle between AB bar and CD bar? Then what can you say? AB bar is nothing but Z2 minus Z1. CD bar is nothing but Z4 minus Z3. Argument of this is nothing but argument or amplitude, whatever you call, is nothing but the angle between the two lines joining, Z1, Z2 and Z3, Z4. You can make use of the angles made by etc. Right? If Z1, Z2, Z3 and Z4 are vertices of a square, then this becomes 90. This becomes 90. Moreover, mod Z2 minus Z1 is equal to mod Z2 minus Z4 is equal to mod Z4 minus Z3 is equal to mod Z3 minus Z1. Why? Because they are nothing but the sides along the square. All the sides are equal. Moreover, you can say one more thing also. In a square, the diagonals are also equal. What are the diagonals? Z1, Z2, Z3, Z4. Z1 minus Z3, mod Z1 minus Z3 is equal to mod Z2 minus Z4. You can have diagonals are also equal. One more thing you will be able to verify and use, that is angle between the diagonals is also 90. That is argument of Z2 minus argument of Z3 minus Z1 by Z4 minus Z2 is also 90, like that. So a wide range of utility can be observed of these concepts in terms of amplitudes.